Hello students, welcome back to the Chemistry YouTube channel. In this lecture, we try to discuss very important term, that is radius ratio, and at the end of the lecture, we try to discuss the very important questions from previous exams. So starting with the term radius ratio. So the word itself indicates that it is the ratio, right? It is the ratio. What is meant by radius ratio? So it is the ratio of radius of cation to the radius of anion. So radius ratio is nothing but what? Radius ratio is equal to radius of cation divided by the radius of anion. So it is ratio of radius of cation to the radius of anion. Okay, as you know, the size of cation is generally smaller than the size of anion. That is the general statement. Generally, the size of cation, right, is always, we can say, smaller than the size of anion. That is the general. It may be vice versa. Okay, but general statement is size of cation is generally smaller than the size of anion. If the size of cation is smaller than the size of anion, and then ratio should be 0 point something. Okay, right? If you observe the table, now what is the use of radius ratio? Radius ratio is used to determine the coordination number and the structure of the compound. What is the use, application of radius ratio? If you know the radius of cation, radius of anion, you can calculate radius ratio, and from radius ratio you can predict coordination number and the structure, geometry of the crystal. Okay, so you already know coordination number in terms of positive, negative, right? In terms of ionic compound, the coordination number is the number of oppositely charged ions surrounding central ion. Okay, so radius ratio, radius of cation to the radius of anion. What is effect of radius ratio on coordination number? Now, if you consider these anions and these are the cations, okay, anion and cation. So anions are generally larger than cation. Okay, so anion creates an void. So this is, we can say this is void, and in that void cation get trapped, right? Okay, as the size of cation, as the size of void, as the size of cation decreases, what about the radius ratio? 0.732, right? 0.414 and less than 0.414. That means as the size of cation decreases, radius ratio, what we can say? As the size of cation decreases, right, radius ratio decreases from here it's greater than 0.732, right, and here less than 0.414. That means as the size of cation decreases, radius ratio decreases. If radius ratio decreases, here is the coordination number. Central sphere 4 above and 4 below, coordination number is 8. So coordination number increases from 6 to 8, from here to here, 6 to 8. Now here coordination number decreases from 6 to 3. So we can say size of cation decreases, radius ratio decreases, coordination number also decreases. So radius ratio is directly proportional to coordination number. Radius ratio is directly proportional to what? Coordination number. So now next is table that shows us relation between radius ratio, coordination number, and what? And the shape, geometry, we can say the structure of the crystal, of the molecule. Okay, if radius ratio lies below 0.155, right, the coordination number is 2 and the structure should be linear. If it is lying in between lower limit and upper limit, lower limit is 0.155, upper limit 0.225, the structure is planar triangular and coordination number is 3, right? If radius ratio is lying in between 0.225 to 0.414, right? The structure geometry is tetrahedral, coordination number is 4, example is ZNS. Example is ZNS. If it is lying in between 0.414 to 0.732, right? The geometry is octahedral and the coordination number is 6, right? And if it is lying in between, radius ratio is lying in between, right? 0.732 to 1 or above than 1, then the structure shape geometry is body centered cubic, you can say cubic, and the coordination number is in 8, top 4 corner and bottom 4 corner in BCC, body centered cubic. Examples are cesium chloride, cesium bromide, cesium iodide. In case of octahedral, the examples are NaCl, calcium oxide and magnesium oxide. Okay, so you must know this table, because this table gives an information about coordination number and the geometry related with radius ratio. You must know the radius ratio, lower limit and upper limit. Okay, lower limit and upper limit. So if you get back to the previous slide, what you observe? If you observe this black circle, we can say sphere, now it is called as void. Okay, so there are two types of void, right? One is tetrahedral and other is octahedral. So voids are two types. Voids are of two types, right? Tetrahedral and octahedral void. Tetrahedral and octahedral void, right? If you know the radius, we can say radius r, and here radius small r. So small r is the radius of void and the capital R is the radius of the sphere forming void. Okay, so for tetrahedral and for octahedral, what is the relation? For tetrahedral, small r divided by r is equal to 0.225 for tetrahedral. For octahedral, small r divided by capital R is equal to 0.414, right? If in numerical they give radius of the sphere forming the void, automatically you can calculate the radius of the void, that is octahedral void or tetrahedral void. If they give radius of the sphere capital R, you can able to calculate radius of the void. Voids are of two types, octahedral and tetrahedral. Okay, so we are moving to next part. The next part is MCQ from previous exams regarding these two equations. Okay, so radius of tetrahedral void, how can we calculate radius of tetrahedral void, right? So this is r is the radius of void, r radius of sphere capital R, small r is the radius of void, capital R radius of sphere. For tetrahedral it is 0.225, for octahedral it is 0.414. So you can calculate radius of void, any void, if radius of element or radius of sphere is given. Now MCQ number first, which is asked in NEET 2016. The first MCQ is the ionic radii of A plus and B minus are respectively 0.98 into 10 raised to minus 10 meter and 1.81 into 10 raised to minus 10 meter. Okay, respectively. The coordination number of each ion in AB is. Now radius of cation is given, radius of anion is given. Now what you can do, you can calculate the radius ratio, and upon radius ratio from this table, last table, you can calculate coordination number. So now my job is to calculate radius ratio. radius of cation divided by radius of anion means radius of A plus divided by radius of B minus. The respectively are 0.98 into 10 raised to minus 10 picometer, right? How much it is for B minus? 1.81 into 10 raised to minus 10 picometer. Okay, picometer, 10 raised to minus 7, 10 raised to minus 7, cancel. Now what can I do? Very simple, just shift decimal point by 1 digit. Here also shift decimal point by 1 unit. Now it is 9.8 and it is 18.1. Okay, if you round up into 9, what is the answer? And cancel this one. So 9 twos are. So approximately, I am calculating approximately 1 by 2, and 1 by 2 is nothing but 0.5. If you observe, right, if you observe the table, 0.5, here for linear it is less than 0.11155, for planar triangular it is lying in between 0.155 and 0.225, for tetrahedral it is lying between 0.225 0.414, and for octahedral this 0.5 value lies in between 0.414 and 0.732. That means, right, this AB form octahedral structure. So we can say AB form octahedral structure, okay, with coordination number. Coordination number is 6. They are asking about the coordination number. What is the coordination number for octahedral? No doubt, coordination number is 6. Coordination number is 6. Okay. Now, if MCQ is asked in another way, what is the way? If they are giving us the value of B minus, radius of B minus, and if they are asking about the radius of A plus, then it is simple to calculate. How it can be calculated, right? R plus divided by R minus is equal to, what is the answer? 0.5, right? 0.5. So they are asking about the R minus, then what can I do? R plus, right, divided by 0.5 is equal to R minus. So you can easily calculate radius of any cation or anion, right? If the radius ratio is given, if the radius ratio is given, then you can calculate radius of cation or radius of anion. Okay, chalo. Now we are moving to next MCQ. An element crystallized in FCC lattice with edge length of 400 picometer. Calculate the maximum diameter of atom which can be placed in interstitial. It is a spelling mistake. Interstitial site without distorting the structure. IIT JEE 2005. Right. Now it is very simple. FCC. You know the FCC structure. Very simple. FCC structure. You can able to draw the FCC structure. This is 8 elements at the corner and one element at the center of each face. Okay, this is the FCC of given element. Now edge length is what? Edge length A is 400 picometer, and they are asking about the calculate maximum diameter, not radius, diameter. Ata what is the relation between diameter and radius? Diameter is equal to 2r. So if you calculate radius, multiply by 2, it is converted to diameter. Okay, calculate maximum diameter of atom which can be placed in interstitial site without distorting the structure. Okay, so maximum, word maximum is most important, right? Then interstitial site. So interstitial site is wide, no doubt, wide. Okay, Now, for FC structure, for any structure we can say, for FC structure there are two types of void. There are two types of void. Which one? This is tetrahedral void and this is octahedral void. There are two types of void, tetrahedral, octahedral void. So, if you look at the word maximum, tetrahedral void has smaller size than octahedral void. So, you have to place, right, atom in which void? Octahedral void. And then neglect about tetrahedral, go to octahedral void. And for octahedral void, R void is equal to, what is the equation? Last slide, right? 0.414 into, right, radius of sphere. Radius of sphere. Now they give us the edge length. So for FCC, okay. Now you have to calculate the radius of sphere. Radius of sphere. So you must know the relation for FCC, right? For FCC, what is the relation for face diagonal? 4R is equal to root 2A. They provide in numerical A, that is the edge length, and you have to calculate the radius of this sphere. Okay, we can say here capital R. Now, therefore, R is equal to, what we can write now? Root 2 is 1 point. Root 2 is 1 point. 1 point how much? 1.414 into how much? A is 400 picometer, okay, divided by 4. Divided by 4. So you calculate first capital R. So what is the capital R? 100, okay. So R is equal to 1.414 into how much? Into 100. Now, what is the void? R of void, that is octahedral void we can say. So therefore, put the value of this R, capital R, here in equation number 1 we can say, right? So R void is equal to, right, is equal to 1.414 into 100 into, right, you can say 0 and 1.414. Now it is very simple to calculate our last trick to calculate the multiplication. Neglect about the decimal point. So you can write here 1414. Okay, very simple. And multiplied by how much? 414. 414. Okay, very simple. Now 4 ones are 4, 4 fours are 16, 4 ones are 4, 4 ones are 16. Here is 1, so 1, 0, 4, 0, 1, right? And 4 ones are 4 once again. Now here, same 4, 1, 6, 0, 4 and 1, 6. Diagonally add 6, 9, 6 and 7, 6, 12 and 13, 3, add 1, 6, 10, 11, 15, 5, add 1, 6 and 7 and 8, 8, 4 and 5, 0. So this is the answer. Now 585, 396, okay. There are 3 and here is the 336. So answer is 0.585396 into 100. So you have to shift the point by 2 digits. So automatically answer is 58.53. So this is the radius in picometer we can say. Radius of what? Radius of void. Now they are not asking about the radius. They are asking about the diameter. Multiply by 2. Just you multiply by 2. If you multiply, right, diameter is equal to 2R is equal to, we can say 58.53. 53. Just multiply by 2. What we get? We get 117 picometer. That is the answer, right? You can use this trick to calculate the to multiply the big numbers. Okay, thank you. Thank you so much for watching. If you like, share and subscribe. Thank you so much.